Hi, my name is Bismi, and this is my Lab 9 final project for ENME351. What I made for my project is an under-the-desk cord concealment device. I wanted to do this because, unfortunately, during a busy semester, my desk will get super cluttered. There's hardly any room for my cords, which are usually on the ground, so I made a system that will both anchor my cord and pull it into my hand's reach when I need it. The first step is the sensing. I am using an HC SR04 ultrasonic distance sensor, which can detect reflected waves. The sensor will utilize a carrier signal method with an inaudible sound wave in order to differentiate from the other signals, similar to NEC protocol, which we learned about in this class. It has a trigger or ping pin, which sends out sonic waves above a human's hearing range, but it'll only do this if the pin gets activated at a high state for 10 microseconds, upon which it emits 8 cycles of a 40 kilohertz wave at the speed of sound. The echo pin, meanwhile, looks for these pulses after the waves hit an object and come back. It can provide the time it took to travel there and back, which we can use to then get the distance that it covered in that time. Once this information gets processed by the microcontroller, I'm using the Arduino here to control a microservo that's connected to a 3D printed actuator. When the servo sweeps to one side, it pushes it forward. This is the Arduino code. I've defined my trig and servo pins as output, and the echo pin is searching for reflected waves as an input, and I've begun serial communication. I trigger the sensor, applying the 10 microsecond pulse, which starts the ultrasonic waves. This part was borrowed from the Maker Pro YouTube channel. Then I use pulse in as a timer to show how long the echo pin stays in a high state. Utilizing the speed of sound through the air as 340 meters per second, I can calculate the distance of my hand from the sensor and send that to the serial port as well. When a hand is close to the sensor, the servo sweeps to 180 degrees, sliding out the cord, and I send the status as open. When nothing engages the sensor, however, the servo pulls the cord back in, and the status is sent to the serial port as closed. Meanwhile, processing displays all this information when the sensor is in use. It gives you the status of the cord concealment system. When the sensor isn't engaged, it lets you know. And when the cord gets pulled out, it lets you know that you are ready to charge up your phone. And this image of the charger and pull-out tray or arm pops up. This is the processing code. I uploaded the necessary images and prepared processing to basically retrieve data from Arduino on the serial port. You have a window size of 1200 by 800, which matches my background image. I ensure that the sketch only works when the port isn't being used by Arduino. Avoid any null or unnecessary info in the strings. Split up the values of hand distance from the sensor and the status of the cord that I'm printing. To make things more efficient, I decided to do my conditional statements actually based on whether certain words are present in the serial stream. If processing detects open in the stream because the cord is pulled out, it makes an image of the tray and battery and a text indication. But if it detects closed as the status, then it provides a different text indication. And the function charge ready just simplifies the main code by running through the icons that I use to make the image down here. This is just a look at the actuator. It's a 3D printed part with a place to hold the microservo. That got secured with epoxy. This gear interacts with the rack and converts the rotation of the servo into this linear motion. And that is my final project. Thank you.